All right, the last part of 9.4 here, we're going to talk about solving some logarithmic equations. Why on earth would we ever need to know any of these rules? I kept saying, you don't know what you're going to use this yet for. You don't know what you're going to use this yet for. When you see stuff like this, oops, pardon me, worst arrow ever drawn, you're going to need to use stuff like that. Okay, so we're already at a point where we're going to take these things out of the toolbox. Okay, they may not always be necessary though. Log equations come in so many flavors. So I tried to grab as many as I could and put them here for you. But that doesn't mean these are all the ways you could see logs. Okay, log is just another sprinkled layer to solving equations in general. So it's the same idea. How do I fix the log? Let's look at this first one here. This first one is not too bad. It just has one single log in it. So we can go maybe to like the base idea. More importantly, here's my x. That's my x right there. That's the thing I want to say, x equals. So I'm going to the outside of x. The first thing I see, the first issue I see is the log 3. How do you get rid of a log 3? In this case, let's just undo it. 6x plus 5 is the answer to 3 squared. That's what log means. What power takes 3 and gives you 6x plus 5? That power was 2. So I can rewrite it like that. Now I can clean this up a little bit as not 3 squared, but 9. This is an example. This is an equation we've seen since probably 8th grade. We subtract 5 now. We get 6x equals 4. And then we divide by 6. And x is equal to, reduce it a little bit, 2/3. Okay, so not too bad, just another layer to deal with. Let's try, since those ones are so, I don't want to say generic, but we've seen stuff like that. We've used stuff like that in one of the previous examples when we were first introduced to logs. Ones we didn't see were things like this that had 2 logs, okay? But this is very similar to something like 2 times 6x plus 1 equals 2 times 3. Well, if you're multiplying by 2 on both sides, you're not doing anything. Remember, if you have something happening on both sides, you haven't changed the equation. That's the rudimentary property of algebra. That's the fundamental algebra property. 2 both sides is the same. So, if you're taking the log 10 of both sides, you could undo that with a double circle, right? A double swooshy. Or you could say, I'm not really taking the log at all. They're canceling each other out, is basically what's happening. Log 10 of this thing is equal to log 10 of that thing. So this thing is that thing. However you want to look at it, the logs cancel each other out. Now remember, they are the same base here. They are exactly the same thing. Multiplying by 2 on one side and 3 on the other, that's not the same. But if these are exactly the same, you can drop them away. And so we get 6x minus 1 on both sides is equal to 2. X is equal to 2 over 6, aka x is equal to 1/3. Now this is a coincidence that again we end up with a fraction. I just know that a lot of people struggle with getting fractional answers. Logs do not always produce a fractional answer, just wanted to have more exposure to that. All right. Let's look at something similar now. Let's look at this one. This one has 3 logs to it, which is kind of a problem. I cannot just cancel all these out. But if I could force this to look like B, where I had a single log on both sides, then I could cancel this out. So is there a way I could change this left-hand side so that it was a single log? Oh, wait a minute. The first half of this section, right? We have all these rules for logs, and so I can combine these two. They are the same log base. They are being subtracted, which means their arguments are being divided. Careful, not multiplied, not added, not subtracted, but divided. And we end up getting something that looks like this. So we first use a property to squish the logs together. Why did we want to do that? Remember, you got to move with purpose when solving equations. I did that because I wanted to be able to cancel the logs. Now that I have no more logs in my way. Okay, now I've ended up at a rational, which kind of sucks, but I think this one's pretty easy to fix. I'm going to move that t to the other side, the bottom t, via multiplication. And we get 3t plus 2 equals 4t minus 3t to both sides. We'll go over here. We get that 2 equals 1t, aka t equals 2. So it wasn't too bad after that. All right, let's try another one of those. Here, I do also see 2 logs. But there's no log over there. So do I want to do the same thing? I think so. I think anytime we have a couple logs, it's just going to be in our best interest to try and get rid, to try and squish those into one log. It's always easier to deal with one log than a couple logs. So let's see if this helps us. Let's put these two together. Can we? Yes, they are the same log. So I can combine them together to log 2. But of what? Well, these are the 2 arguments, and since they're adding, I will multiply. Be careful to multiply and not add to 2x minus 7, but actually multiply. I could rewrite that and actually multiply that in. We get x squared minus 7x is equal to 3. That doesn't entirely solve my log problem, right? But now this is looking strikingly similar to this first one up here. How did I solve it that way? I made the circle. And so this, if I rewrite it as an exponent, is 2 to the third, otherwise known as 8. Okay, and now the log has dropped away. How do I solve this? Well, I've got a square and a single x. There's no way to undo those unless you're talking quadratics and factoring, so I'm going to move that 8 to the other side. Minus 8 equals 0. A quick factor, because I do know 2 factors that multiply to negative 8 and add to negative 7. I do believe negative 8 and positive 1 equal to 0. And so we get the 2 answers of x equals 8 and x equals negative 1. Small issue here, though. Small issue here. Looking at that guy, going over here. I'm going to do this in a different color. Remember back when we were graphing, when we said the domain couldn't be negative numbers? That's still a problem. That's still a problem. So log 2 of negative 1, I don't know, we'll call it y. 2 to the y equals negative 1 does not exist. That's not possible. And so this is what we call an extraneous solution. Not every quadratic will end up in extraneous solutions, but anytime you get a negative number for x, you will want to double check. In fact, you really should check all your answers just so they don't produce negatives, but 8 is actually fine. 8 minus 7 is still a positive 1. 8 and the other one actually gives us a whole 3, but negative 1 does not exist, and so it cannot be our answer, and so our only answer is x equals 8. So put a star by D here, just so you know, sometimes you get some extra garbage answers. Alrighty, over here on 6, this is very similar to that one, another chance to try that. What happens when you have 2 logs? Probably a good idea to squish those together. I've got a minus, and so my arguments will be divided. Now, this is very similar to the very first one, A. I'm going to unwrap it with this guy here. 2 over x is the answer when you take 6 and make it to the third power. 6 to the third power is 216. 36, yeah, 216. Okay, be careful of this. I'm not going to multiply 2 on both sides, even though that would be nice. I'm going to multiply x to both sides. I get 216 times x. Divide by 216 now to both sides. I don't know why I made 1 bar, sorry. We get 1 over 104. 108, pardon me. 108 is equal to x, which is not negative. So even though it's crazy small and crazy weird, it's still positive. So we're not having any issues. All right, last but not least, let's see. I've got so many logs here. Too many logs here. But I think I do see logs on both sides. I'll log 4. So if I can make one of each, then I can cancel them. Right? One of each, I can cancel them, right? And if I have 2 times 2 on one side and only 1 2 on the other, I can't cancel those. But if I have a single 2 on both sides, I can cancel them. Same thing with the logs here. So I do have log 4, log 4. They are being added, and so these arguments will multiply to 3 times x squared. Log on the other side. Oh, that's so convenient. No circles. I can just now cancel those things out. I get the arguments are equal to each other. Divide by 3, we get x squared is equal to 9. Square root, you get 2 answers, plus and minus 9, thanks to algebra. But we know, is this answer actually extraneous? Let's take a look at that. We've got 3. and -3, because the square root of 9, not just 9. Is it actually extraneous, though? Remember, we just want to double check. If we put that negative in there, it gets squared back to 9, and it's actually okay. It's actually okay. And so these two are both fine. They are both algebra. Doesn't mean they're functions, but they are both algebraically okay. All right, that is the end of chapter 9. Section 9.4. I will see you again in 9.5 when we talk about some applications.